My name is Livesi from DCS2G6. In this video, me and my teammate will explain about our network design. For the departments in location A, the maximum number of hosts needed is 50 hosts, which is the administrative department. Since this is a classful LAN, each subnet in location A should have 64 hosts with 6 host bits and a prefix of 36. With that being said, location A requires 2 network addresses, where each network address is segmented into 4 subnets with 64 hosts respectively. However, there are only 5 departments in location A, therefore only 3 subnets of the first network address and 2 subnets of the second network address are being used. In each subnet, the first host address is used as the subnet address, whereas the last IP address is used as the broadcast address for respective subnet. Therefore, there is only 62 assignable IP addresses in each subnet in location A. By default, private Class C network can provide a maximum of 254 hosts in the network. Therefore, it can provide sufficient IP addresses for each subnet in location A. In our network design, we have standardized to assign the first usable IP address in each subnet to the router port that serves as the default gateway, followed by the switches and the end devices. Now I would like to show a few examples of ping connectivity in location A. The first example, I will ping from a PC in location A to another PC in another subnet within location A. I see that the first ping is failed because an ARP broadcast was being sent to learn the MAC address of the destination device, which will also put the ping request on hold, resulting in request timeout and failed ping request. Now I will ping for the second time. You can see that it is successful because ARP broadcast is no longer required. For the second example, I will ping from a PC in location A to a PC in location B. As I have mentioned, the first ping is failed because of ARP broadcast. Now I will ping again. You can see that it is successful now. Next, I would like to explain the topology design in location A. The switch-to-switch connection is designed using star topology, where the end devices are connected to sub-switches, and each sub-switch is connected to the main switch, and the main switch is then connected to the router to allow communications with other subnets. In this star topology, we are using fast Ethernet port to establish a connection between the PCs and the sub-switches, as well as the connection between the sub-switches to the main switch. With data rates up to 100 megabit per second offered by fast Ethernet, we expect that it provides adequate bandwidth requirement and it should be able to support the network traffic generated by the host. Next, I would like to explain the connection between router to router. We are using a separate network address for router-to-router connection because we want to avoid wasting assignable addresses in this LAN. We are using a separate network address with 2 host bits and a prefix of 30 because there is only 2 hosts in each subnet, which are the routers. In this case, if we use the remaining subnets from location A, which can support up to 64 hosts in this router-to-router connection, there would be 60 usable IP addresses being wasted. Besides, using a separate network address for router-to-router connection can also improve the scalability and allow easier network management because we can focus on the routers and their connections separately from the main network. Lastly, for the routers in location A, we have configured EIGRP as a routing protocol to provide a more efficient routing within the LAN. Next, I will pass it to Zhenxiang and he will explain the network design for location B.
I'm Lim Zhenxiang from DCS G6. Now I would like to explain the network design in location B. As mentioned in requirement, we expect a 20% growth of number of hosts in each faculty. So we have to implement the subnet design according to the increased number of hosts. We have 4 faculty here, so we use 4 subnet, which each faculty will be only using a single subnet. As the largest number of expected hosts is 720 hosts in Faculty of Innovation and Technology, using classful addressing scheme, there will be 10 host bits in each faculty, and each faculty will have the range of 1024 IP address, with only 1022 assignable IP address. And we use the router in location B to connect with each faculty, and we implement the EIGRP routing protocol to allow the router to communicate with every other subnet, including the subnet in location A. About the addressing design, we use a Class B private IP address to cope with large number of hosts in each faculty. For the router, we assign a first assignable IP address of each subnet, and the second assignable IP address will be assigned to the switch, and the next assignable IP address will be assigned to the host, and so on. Between the router-to-router connection, we use a Class C private IP address to establish the communication between router in location B and router in location A, which is a separate network from the network address in location B. Now I would like to show some ping connectivity example. For example, here I ping PC1 to the another subnet within location B. For example, here PC1. For the first ping, it will usually fail because the router has to put a ping request on hold and send the ARP broadcast to learn the MAC address of the remote device. This process usually took some time, so causing the first ping to request timeout. Now let us ping again. The second ping. For the second scenario, let us ping a device from location B to another device in location A. As I mentioned, the first ping will usually fail, but for the second ping, it will be success. Lastly, I would like to explain on the topology design between switch-to-switch connections in location B. As you can see, we use star topology between switch-to-switch connection in location A, where each subswitch have to connect to the main switch. But in location B, there will be large number of hosts. If we use star topology, each subswitch have to compromise on using fast Ethernet interface to connect to the main switch due to not enough number of gigabit Ethernet port of the main switch. Hence, result in heavy network traffic due to bandwidth limitations, and the network congestions could reduce the network performance. To avoid that, we use bus topology so that it could offer sufficient gigabit Ethernet port between switches, providing higher bandwidth and faster communications in switch-to-switch connections. This could guarantee a smooth network performance in location B. That's all from us. Thank you.